Uh, so it was about 2 years ago. My manager comes to my desk and asks me, hey Massoud, we want AI in our application. And I was like this, yeah, that's a great idea. We can integrate AI in our application. And suddenly he continued and say we have serious limitations. We can't use online AI providers because of the company policy. We can't let our data goes to external APIs. Then I asked him, what about open source models that we can use GPUs on our servers? But he replied negatively, and he told me the company can't provide GPUs for us. And also we have another limitation that we can't use install any software on consumer device. We can't use anything like Olama, LM Studio, or something like this. So I was thinking about what am I supposed to do? I have no choice. The only thing that left is running LLMs and machine learning models inside the browser. So I started to search about this, and I found out I can run these models entirely on the browser without using any external source or any server. I forgot to introduce myself. I'm Massoud Asadi. I'm a software engineer. I have 10 years of more than 10 years of experience. I have a spinning about different technologies from developing desktop application to work with AI and fine-tuning models. So let's start with cloud AI providers. We get input from the user. We call the third-party API. And the process will go on their servers, and then finally we got a response from them. But in browser, this is different. We got input from user, and we load LLM model directly in our browser runtime, and then we get instance response. So we don't have so there is no cost for us, and there is also zero latency and full privacy. This is good for companies that they don't want the data to leave the device. So some of you might think that we have Olama, we have LM Studio, we have Llama Sharp. So why we need to run LLMs inside the browser? Actually, Olama is good for doing heavy workloads for power users. Like you want to do some agentic coding or video processing, image processing. Yeah, that's a good choice. But for smaller and lighter models, the browser is a better choice because you don't need to install anything. Actually, when you install Llama on your device, you are installing a native desktop app, and it exposes a REST API that other services can use it. It's good for big models, let's say non-billion parameters, 20 billion parameters, yeah, that's great. But for small models like 2 billion parameters, 1 billion parameters, that's definitely a better choice. Because everything runs on the fly and you don't need to install or initialize anything. So why we must use client-side AI? I think the privacy, this is the most important thing for the companies because they have a GDPR, and you know, some manager, they don't want to expose financial data. So the client-side is the best choice for them. Also, we have a zero latency, and the most important thing, offline capability, so we can run our model offline. Let's say you have a PWA application, progressive web apps, that have offline capabilities. So you want your model runs offline too. So this is the best choice for you. You can integrate, and they will work both parallel offline. And also about the cost, when you deploy your model on browser, the actual cost is for the customers using your application, using your model. Because the model will be downloaded on their device and all the processes on the device. So there will no cost for you. There is some real world use cases. Let's say semantic search. You have a bunch of PowerPoints, Excel, and Word files. You want to search among them. You can use RAG and semantic search. There's a good model that's actually 23 megabytes and can do this semantic search for you. It's called AllMiniLM L6 version 2. Also, we have autocomplete, or let's say you have a big form in your application, and users are repeatedly filling the forms. You want to suggest them the previous data that's entered. This is the Kalansaya is the best choice. We have real-time transcription. It means speech to text. We have image analysis and, of course, privacy. What I like the most is the Chrome extensions. You can develop your web browser extension and integrate AI into it. So let's talk about the Transformer.js. It's kind of industry standard library because they have a lot of ready models. They have more than 1,200 pre-converted models. Also, they have a huge community in Hugging Face, and there's a lot of users on GitHub also. Transformers use an Onyx runtime. It's a low-level runtime for running machine learning models. If you want to tweak anything, you can use Onyx directly. But Transformers.js use Onyx. Transformers.js, it's not about only running in browsers. It can deploy to any JavaScript runtime. Let's say you have server, you can use Node.js, Bond, Deno, and Electron. Let's compare this library with some of best open source ones. We have a TensorFlow, of course. They also have a web runtime, but it's not on WebGPU or WebAssembly. It's on WebGL, so it's a little weaker than other runtimes. The downside is it's limited. Not all LLMs can run on it, and also it's best for a small custom trained models. The Onyx runtime web, of course, if you want to do anything low level, you can tweak anything yourself with the help of their APIs. This is not recommended for beginner users. It's the best fit for power users. We have WebLLM. WebLLM, maybe for beginners, it's the best choice because it has a lot of abstract methods that made life easier for them, so they can start very quickly and fast without any prior AI knowledge. And finally, we have MediaPipe. I don't like this one because it's only limited to JAMA models. Let's talk a little about the Onyx runtime. It's a 9 years old cross-platform runtime that was developed by Microsoft and Amazon and Meta. They try to develop best methods to have a highest performance possible that gives you ability to be runs everywhere. Actually, they're using it for Microsoft products like Bing, Office on Web, and also they use it in some part of Azure. So let's see what happens when you use transformers. The first thing is that you must choose your model. Let's say I will choose Llama. It first gets downloaded from Hugging Face. Of course, you can use a local web server if you want. Then after the model will be downloaded, it will be copied to browser cache because it's huge, maybe 1 gigabyte, 2 gigabyte of data. Then the Onyx runtime load the model into the browsers, into the device RAM, and then it will be deployed on web GPU or WebAssembly. Web GPU is preferred because it will use your device GPU directly. It will give you huge performance boost. But we have WebAssembly too. WebAssembly is standardized on all famous browsers. So if you want to be sure that all people can use your application, you must target WebAssembly. And also about the supported tags, it can do anything that other frameworks do, like natural languages, name entity recognition, and table question answering. And about the computer vision too, we have image classification, image segmentation, and also object detection. About the audio, we have a text-to-speech and speech-to-text, and also we have audio classification and recognition too. About the multimodal, most of the models these days support image, videos, like text too. We have a high-level abstract API called Pipeline. It will give you high-level abstract methods that anyone without any prior knowledge of AI can use AI. Let's say I want to process my text. I want a sentiment analysis. So I will classify my task as sentiment analysis in the pipeline method. Then I will get result. It's just 3 lines of code, very simple. What I like about the transformer.js is that it's web worker ready. As you know, browser tabs are limited to single thread. With the help of web worker, you can assign a new task to your model. So your application and model runs parallel. About the performance benchmarks, some dudes on YouTube, I saw that they could run 20 billion parameter model on M4 Pro Max, and they could get 60 tokens per second. I think that's impressive for web. They also use the BERT-based embeddings with multi-head attention, so they will get a huge performance boost. And about the runtimes, when you run your model inside the web GPU, you will get much faster responses. But it depends on your device. If you have a decent GPU, the model will be run on GPU directly. But the laptops without GPUs, there is no noticeable difference between WebAssembly and WebGPU. The Transformer.js community recommended this library and runtime for models below 2 billion parameters. But in my experience, I will half it, and I think it's suited for 1 billion or less parameter models. If you are interested, you can start building today. You can install Hugging Face transformers with the Node Package Manager. Also, the URL for documentation, GitHub, and for the models, I will show you after the slides. So if you open Hugging Face website and navigate to model section, you can open the libraries tab and you can use Transformer.js. It will show you all the models that are compatible with Transformer.js, so you can easily run your models on it. You can also choose your task, choose your languages, and other things. So that's it. Any question? I think no one was interested. She has a question.
Thank you for the speech. And my main question is, like, what's your real-world usage and what's the reviews from the users? Like, how they experience it? Was there, like, what's the bottleneck and challenges with this implementation?
Yes, you know, the real limitation and real challenge is that you must use weak models. Let's say 1 billion parameters or 200, 300 million parameters. So you cannot do anything that need a huge amount of power. So it's good for a simple task. Let's say you want to use Gemma 1 million parameter. It's a 1 gigabyte model, and you want to develop application that responds to your commands. You can define a list of commands. Let's say navigate to another URL. Let's say send email. For example, call this person, something like this. You can combine it with, let's say, Chrome extension and develop some real products. And about the real-world usage, when I was in my country, we developed real production-grade application with it. We combined Gemma, this 1 billion parameter model, with the embedding Gemma. So we extracted the data from different files, from different type of files. Let's say PowerPoints, Words, Excel. Managers had a lot of Excel files. And we extract the text from them, vectorize them, and give it to the embedded model. It vectorized successfully, and then we get response. And you know, the problem with embedding models is that they always produce the repetitive answers. So if you want to be your response to be natural, you must give your response to LLM and rephrase it for you. It is also good if you have a mobile application. Let's say, did you see the text-to-speech ability?
Yeah.
It was the Whisper Tiny model from OpenAI. If you want, you can get a quantized model for 14 megabytes. So.
And the main question was about the performance, like how users reviews, or is there some complaints about the performance?
I told you, if you use the weak models, small models, the performance is okay. This device is a 4 years old device. It's a used CPU model. It's for low power. And I also limit the threads to be just one thread. So it's like a normal JavaScript application run in a browser. So if you keep your model small, and if you use web GPU or use WebAssembly, the performance is great, even for low-end users. But if you want to use big models, let's say Llama, Queen, or Gemma 4, they are big models, 9 billion parameters, 20 billion parameters. That's not the case. And you ask a question, it will take 5 minutes, 10 minutes to get a response. But did you see the Gemma 1 billion parameters respond you immediately?
Okay, thank you.
Okay, it's great for when you don't want to use cloud AI providers or you don't have GPUs in your company servers. If you don't have any other choice, this is the best option.